tuning rules. These are in stone. They never change, ever. That's rule 1. It is absolute. I've never seen that one fail. Except when it appears to be working, come back and look at it. Because whatever you think you've got it all completely sorted out, you'll find out something's gone wrong. Now I broke something else. Happens all the time. There's also a corollary to these basics, and that is there's always more to improve. This is part of the, excuse me, the art of the process, which is knowing when to stop. If whatever you do in a performance world, there's always something that's the worst. And the real art is finding when to stop. So, first stage of our tuning exercise is really to find out what's wrong. Where is our performance problems? Are they in the app server, in the database? Are they in the load balancer or the network? Is it our users during the day that's the problem? Or at nighttime, if we're running jobs, we're running long reports, are those reports still running at 8 a.m. in the morning? Sometimes they are, sometimes they're not. Those kind of boil down to read or write issues. And the reason you want to know think about this ahead of time and analyze it, that's later on, is you want to look in the right place. If your problem is in your network, there's no point in spending hours and hours and hours in the database. We have a whole series of tools that we use internally. Some of the people in this room are more familiar with them than others. Michael, of course, is completely familiar with all of them. If you have any questions about this, you should ask him. He's my boss.
That's where we have Dave.
Yeah. So Oracle has some great tools. We have some application monitor tools. I'll show you some of that later on. We look at the network activity, and very simplistically, we like to look at the Tomcat logs, because that'll tell us what the app server thinks it's doing, and it's very uninvasive. Let's start with the network. Usually when you develop your systems, you'll work in a small environment. Your database will be physically very close to your application servers. You'll be missing such things as the load balancers and the firewalls. You probably won't be using SSL or SSO in those environments. So that's something that you need to consider when you're doing your performance testing, is what will my production environments look like? Because if you run your test in the development environment, you're missing a huge part of the validation. That's the network level. In the production environments, the topology can matter too. I worked on a system in a previous job where the users were in London. They were accessing a system that was in Germany, and each message was going via India and Hong Kong. And then they wondered why their development system was slow. Obviously, most of our DTOs don't really have that, but the same thing can apply. I know a lot of you have internally outsourced IT, so you have the same kind of environments where it's hopping around. The single sign-on, again, that can be an extra loop in everything. It goes forwards and backwards. Okay. The other thing to consider here is not just SSO, but the SSL. Typically, you want to terminate your security as soon as you can, because if you keep re-encrypting and de-encrypting the messages as they go through the system, it's going to make it really, really slow. There's no need for the inner firewalls, despite what the IT people will try and tell you, and the database people want a wall around themselves. It's like, get them out of that mode. So, our application servers. It's really important to find out what is going on within these. What we have done in 7.3 is we've started instrumenting our code from the inside out. So what that means is that in any installed environment, we have logging that we can turn on. We can tell you exactly how much time we spend in a database update, a database delete, a database query. You can run this in any environment. It's a little invasive, so I wouldn't advise it in a production environment because it's writing to a flat file and it can write a lot of stuff. There's a lot of reads and updates. The other really cool instrumentation tool that we use is a thing called JProfiler, and I'll show you a little bit of that later on. That allows you to basically look at the application as it's running. It's really looking for issues within the application code as much as anything. Although in a lot of the configuration code, there's a lot of Groovy scripts. Those occasionally show up in our lists of things to fix. So we have a performance logger that sits around the Groovy scripts, and if you look at the profiler, you can see them in there as well. This is the only way to solve the application problems, and we do see this quite a lot. As sizing, this is an interesting problem. It's becoming more and more obvious as life goes on. So your production system, you're probably going to size for however many users you have. If you have 1,000 users, you might have 4 servers sitting there. You know what your load patterns are. So for people that are doing a lot of work orders, you'll see typically Friday, Monday, there's a big peak in traffic. But probably the rest of the week, you don't have much traffic. What that kind of points towards is get your IT to figure out how to dynamically scale your load. Because if you're paying by the server and you only need 2 servers during the week, maybe that's what you want to have. And just say, come Monday morning, I need 4 up and running. Come Friday, 12 o'clock, I need 4 up and running, or Thursday, whatever the day happens to be. Because performance is really perceived. It's not necessarily about how fast individual things are, it's about what users see. The other thing about sizing, I don't think is here, is training and testing. The training environment is typically the biggest load of all. I'll say that again. Training is big. Kind of counterintuitive, I only got 10 people in the room. But at TechStop, for example, when they do training, they do analysis training. Their normal load on that is at most 5 people. When they're in the training room, they have 10 guys or girls sitting there, and basically they get to a certain point in the program, and it's basically press the button. And suddenly you have a massive load beyond what the production system is designed for. So that's where we use, in the SaaS environment, that's where we use dynamic scaling to handle that load for that small period. And typically for us, it's a day that we set it up for. They prearrange it, we're good. The background jobs that we have, those run in one of the application servers. It's really a good idea to have that server not processing web requests, especially if you have jobs scheduled during the day. If you look at your job schedules and everything is running at night, probably that server can handle the day load. But if you're running stuff during the day, that's going to have a really adverse effect on your users for something that you could just push basically offline. The other thing on the actual jobs is, are they sequential, or are they partially parallel or completely parallel? A lot of the jobs go after the same data tables. And if they're running in parallel, Oracle says it doesn't have row locks. There's a couple of things like lies, damn lies, statistics. The same is true of what Oracle say their database does. It can lock up pretty badly, Jeremy. So you want to look at when your jobs start, when they finish, and make sure that critical jobs that shouldn't be overlapping don't. Memory. Lots of memory. Now, you'd think this is one of the things that violates the nothing works all the time, but apparently it doesn't. Because there's this thing called garbage collection in our Java code. What that does is try to reclaim all the memory that we've used. And if you don't configure this properly, you set the minimum memory too low, it will think it can go back to 2K, 2 gig rather, when it's never going to get past 6. And it will just spin in there and spend a lot of time. So that's one lesson I learned the hard way. Same with a lot of these, actually, was that if you don't configure the garbage collection correctly on there, it doesn't work. And what comes out of the box usually isn't very good. That's a good reference from Oracle on the tuning parameters. I would just give that to the application guys. I'm going to try and stay very high level today and not go down way into the depths. Okay, so as I said before, training, that's the biggest load. But it's only a very short term. The other thing that we want to do when we're load testing is actually look at the users and what the different roles are doing. So for example, you have a role that we're using the personas for them, but say the yard managers, those are the guys who are doing their work orders and their day cards. They're typically coming in at fairly fixed periods of the days. Whereas if you have people doing analysis, they'll be doing it throughout the day, but very infrequently. So you want to know which users are, what their roles are, and when they're going to do their work, so that you can actually accurately size and plan your performance tests. So for example, I think it was TechStock was saying that their annual performance plans are due this month. So they have a lot of activity that's now overlapping their, or if they use maintenance, would overlap their maintenance. So they have a period where their load is completely different than it is the rest of the year. And again, if you have dynamic scaling, you can go around it, but otherwise you've got to size for it. The interfaces can be problematic. Some of them import huge amounts of data. So a full LRS import, for example, that's a lot of data. It takes a lot of time. Sometimes you have to schedule that to run during the weekend. That's just part of your tuning. And the bottom one is the representative loads. If you use a tool to create performance tests, JMeter is one of the ones we use. It's possible to make it just run through screens instantaneously. It's just going to it's not actually going to use the screens, it's going to capture what was there. So it's as if your users can type at 10,000 characters a second. And So the first time a lot of people use it, they forget that, between all these screens, I kind of need to allow for the fact that by the time I send the data out to display on the web, well, it's going to take the user 5, 10, 15, 20 seconds before they send the response back. And that's the big difference in some of the performance numbers that you can see. Because if you just keep it running around in a really tight loop, effectively you're moving the number of users that the system really thinks it's dealing with way, way up. Because if you have 100 users, they're sending one request every 20 seconds each. You've got 5 a second. If you're just turning it around instantly, you've got 100 a second. So there's a big difference in what the performance test is actually doing compared to what it really is doing. The other really big thing with the performance testing is to spread it out kind of the same way it would be in your production system. So spread it out across admin units, across districts or parishes, users, whatever else makes sense. Because otherwise you end up with some bottlenecks that can have unfortunate database consequences. And when I get to the database section, we'll look at that. The other one is to run these frequently, have them set up. If you have them with JMeter, we'd like to see them. Not to critique them, but we'd like to have them so that we can actually run them internally and see what they are. The environment. Okay. The top 3 are pretty obvious. The SSD is becoming more prevalent nowadays. It's a lot faster than the hard disks. Depends on how you want to use it. There's some tables in the database that are really volatile, where it's really useful. The application servers probably don't care. More memory is usually good, as long as you configure it right. And disk space is for application servers and for the database. In this day and age, they really should never run out of disk space. We've seen a few configurations where we run out of database temporary storage space, or the application server logs fill up that. It's just, when that happens, your system really, really, really slows down. So if you can put more disk on it, then take that approach. Okay.
Can I ask you a question?
Sure.
This may be silly, I'm not particularly technical. So again, when you say more memory is often, when you say more memory is generally good as long as you configure it right, can you talk a little bit about what configuring it right means?
Okay. So we have 2 major processes that use memory. We have a database, and we have an application server. Our application servers, or our application, is written in Java code. So it runs in the Java virtual machine, and when you start that, you tell it how much memory it can use, what's the minimum memory that you want to configure, and there's a few other, there's another 4 or 5 parameters you can set on it. So in the application server, it's pretty easy. There's really only 5 moving parts. The most important one is the total memory. The next most important is the minimum memory. And a lot of the books now say keep those 2 real close. The original memory used to be keep the low one low. But it depends on what your application server does. Ours typically, once it starts running, kind of idles with a 6 to 8 gig memory in use. So if you set the low down to 2, it's going to try walking through all the memory that's been freed. It's looking for 2 bytes, 4 bytes, 6 bytes, which is a waste of time. Whereas it really needs to be just looking for 20K blocks, 100K blocks. So that's the application server. The database server is Oracle. It's order of magnitude more complicated, but the basic principle still applies. It's allocate it a lot of memory, and then within the configuration of Oracle, decide which pieces, or which buffers within Oracle you want to use the memory for. Does that answer your question? Okay. So this is the first eyesight test of the day. This is the JProfiler tool, or a piece of it. This is actually from when Alex and I were analyzing what was happening during the analysis and trying to find out why a piece of it was slow. So you can see that this tells me how much memory is allocated at any given point. It tells me what is actually being created. And the one below the blue line you can see is coordinates. That's where our geometry is. And eventually we traced back our issue that we were creating 2 million geometries in a run, which are basically points for a result that really 9 times out of 10 doesn't need it. That's the power of this tool. There's multiple different uses. You can also see the calling structure and see how much time is spent in individual places. That was one of the ways we found the issues with transactional code that doesn't run well in batch mode that I was talking about in Tuesday morning session. Okay. This is where most of our problems occur. It's a big area. You can configure it in, I always want to take the word almost out of this. I think it's an infinite number of combinations. Yes? Yeah. Yeah. Jeremy's our DBA, by the way. He's sitting at the back. He'll keep me honest. The biggest things to look for is within the database is when do your issues come. It's the same issue with your load. Is your load happening all of the time or just some of the time? Now, the tricky piece with tuning the database is you really want to tune it for the total workload. Or do you want to prioritize your users over your batch runs? So to take an extreme example, when you're doing, I keep going back to work orders, but it's one of the high usage ones. Work orders are reading and are writing a lot of data. Writing data does not like indexes. It's extra work, doesn't want to do it. You could just drop them, a lot of them, or disable them. But at nighttime, when you're running reports, you want those to improve the performance. So you could re-enable them. I don't think that's a very good idea. But in some circumstances, it's kind of what you have to do. Now, the last one is a real positive one. Within the analysis, and it's actually in the system parameters, there's an option to use global temporary tables. This really improves the performance when you're running in a multi-user environment. So in the training example, once we turn this on, the performance goes up 4 or 5-fold because we don't get database contention, which of course Oracle say they don't have, et cetera, et cetera, et cetera, et cetera. Okay, so I see a lot of technical people, so this will be quick. So the database interactions are all SQL. And what the database does is it parses it, it caches it. And once it's done that, it creates an execution plan. That seems very simple. So if it doesn't create one, it can create 1,000 for the same statement. And it will choose what it thinks is the best one. The problem with this is, A, it doesn't always pick the best one, and B, since it caches these guys, sometimes what was good yesterday isn't so good today. You would hope that that's not the case, but that's the reality here. Lots of people, one of the options for the cached one is to go through and actually flush the database caches. So we'll come to that as part of the database maintenance in a while. So here's our database performance. It's all about the optimizer. If it doesn't give you a good plan, you're not going to get fast execution. What do you need to analyze? Well, you need to understand the execution plans. And I'm not going to go down into that detail today because that's probably a 2-day session on its own, going through what is in there. You're going to make mistakes when you look at this. You've got to be prepared to go around it a few times. And the Oracle AWR, that's how you're going to find the issues. Most of this is going to be SQL issues, but there's also database configuration tuning. That's memory, that's buffers, that's disk space. This gets to be a little bit more of the black art. That's where you have a good DBA who will suggest you the right things at the right time. So what is in this magical document? Well, it has a lot more detail of anything that happened than you'll ever need. It runs by default once an hour. Those are called snapshots. And what you can do is you run a report between any two snapshots. There's a section on the SQL. I have a couple of examples down near the end that basically show you the top 10 bad boys. That's where most people start. There's also, it has recommendations on memory and disk use, and it attempts to make an estimate on how much increasing memory at any given point or increasing disk at given points will save you. Those can be really useful. A number of clients this year and last year, when we've looked at this, we've been able to look at it almost immediately and say, well, if you put an extra 4 gig of memory on the database, according to Oracle, your disk usage is going to drop by 80%. And that's really significant because Oracle tends to sort on disk, and that's slow. Which leads to this guy. So this is the happy Snoopy. So we keep our SQL simple as much as we can. That means we don't do things like create views within views, within views that use functions. Yes, I'm looking at you. We have database maintenance because that also helps us get the statistics. That keeps the optimizer happy, the parameterized SQL. Now, on site, one of the things that you can do is look at the indexes. Because the system is so configurable, a lot of the times we don't know what your usage patterns are. Columns are added, columns changed. So adding indexes is often going to help, especially in reporting processing. The second point there on the multi-column, the less data the database has to read, the faster it will work. And if it can resolve which rows to return without actually having to read the rows. So a row typically in a big table is going to be 5, 10K, but the indexes might be 30, 40 bytes. So you can quickly do the math of how much data it has to read for the index versus the actual data rows. If it does that, it's a lot faster. Okay. Database maintenance is sadly one of those not very well understood items. There's a couple of pieces, this is just the list, but the important ones that are not obvious are the index balancing. So an index is basically an upside down tree. And that's how the data is stored. As you add to it, it has a tendency to unbalance itself. So you'll have a tree that starts with 4 layers, and this side will go to 5, and this side might go 5, 6, 7, 8, 9, 10, 11, 12. And it doesn't take much to figure out that when it starts getting deep in one side, some queries are going to run fast, some are going to run slow. So Oracle has functions that you can run, or the DBAs can set up to run on a periodic basis that will balance these back up to a single point. That's a really helpful one. Table defrag. This is kind of the same as the garbage collection for disk, but in this case, what happens is that a row that was in one point gets updated and it moves to another point, and there's a gap left, and then it moves to another point, and there's another gap. So the space that's allocated to the table just grows and grows and grows. So the story on this one is we're having an issue with a customer database. When we brought it in-house, the performance was 10 times faster than it was on their system. And we were looking at the system, it's like everything looks the same. All the execution plans are the same. Everything's working. And then my DBA has this bright idea. Maybe we should go defragment, consolidate the table. Lo and behold, he was right. Okay, so these are advisory rules. Then none of these work 100% of the time. For those of you that write SQL, these are interesting. The first one can have disastrous effects. If you have a 100,000 row table that's joining to a 50,000 row table, if you get the n by m, that comes out at 5 billion rows. That's a lot of data to keep reading backwards and forwards. Most of the other ones, if you look through the web, you'll find most of these. The number 7 here is what we're going to look at quickly. We use several functions, get owner ID, get module ID, get user ID, a lot, through a lot of queries, a lot of reports. The Oracle Optimizer has its own view on these, unless you tell it otherwise. It thinks they're a free lunch. It's like there is no cost involved, and if it's returning a result, it's going to return one of 20 results. So for some of those functions, that's okay. If you write more complex functions that involve processing, you might want to reconsider whether these are free at all. So if you're doing some complex calculation for preventive maintenance schedule, that's obviously not going to be free. So what you can do, apologies for the geeko stuff here, is you can actually tell Oracle what it should think about for each of these functions. Basically, it tells you, or you tell it that the cost of this is X, And when you call get module ID, it's going to return an average of 50 rows. Oh, it's back to front. We have a set of these that we can distribute for. Now we get into the really geeky pieces of the. So this is the impact of bad statistics. The optimizer thinks it's really been clever. It's got something that's going to run really fast in 1 second. When you run it, no. It's at 50 seconds. This is because that table gets filled up and cleaned out really quickly. And this is my favorite toy. So this is the part of the Oracle that you want to look, that we look at a lot. You can see a circle. It's got how many executions a certain piece of SQL was, how long it took. So in this one, you can see that there's a few pieces that are run a lot. 60,000 times in an hour is a lot. So we want to figure out why they're running and address that. And this one, this is one of Oracle's, it's not supposed to do that times, but it ran that query 1,000 times and it spent 50,000 seconds on it. And that was really all the database was doing on it. Everything was in there. So if you need to actually come and tune this, that's where you're going to start. It's like, I might look at the second one in this list. It's 500 seconds. But that top one at 52,000 seconds, that's where I'm going to start. I need to understand why that is done and what's happening. And if you want to actually go down to the level of actually understanding what these drill downs, for instance, that SQL ID one and stuff, that's a longer discussion that really is for technical people and DBAs. And that's all I have.
Okay, thank you, David. We'll now be able to take some questions from within the room. If you have a question, just raise your hand and I'll hand over the mic.
Let's practice.
I'm just trying to get you to walk. So more of a scalability question. If someone is wanting to do training on basic functions, no analyst included, how would you recommend that they would scale their training environment versus their production environment?
Okay, so if you're doing something more of a normal workday type operation, the thing to remember is that when the instructor gets to the now do this, that's when the load hits. So if you have 20 people in the room, you can think at that point in time, you're going to have 20 users clicking the button. And you look, so say your normal load is 1,000 users during the day. They're probably going to click, I don't know, once every 3-5 minutes. So you're probably okay. It's probably the production system or a little bit less. Effectively, what you've done is taken the think time out of your performance test completely for that very small period. And it's going to happen in a series of steps, right? Because when you're doing the training, it's like, okay, fill this form out here. Once you're done, press OK. Wait till everyone's finished. Go through it again and again. And it's each of those hits that's the problem. But you kind of have to look at the numbers.
So we're effectively scaling one user to 50.
Yeah. That's kind of the rough number.
Any more?
I'm done from.
I'd like to talk about the global temporary tables for analysis. Is there a downside to not using the global temporary tables? Because I noticed I'm looking at my system right now, it's not checked in parameters, and I just wonder for some reason somebody decided not to use it.
There's a small overhead the first time you run it because we don't ship with those tables. So it has to enable them. It's not available in Oracle Standard Edition. So if you have one or more of your development or testing systems running that, you'll have issues with it. That's why it's not checked by default. But other than that, by performance-wise, if you're running small numbers of users and they don't all do it at the same time, it doesn't make a lot of difference.
I actually have a problem where I've got 2 users running optimization at the same time. Sometimes one will lock the other out. Will this go to help that?
Yes.
Good.
It might
You're
not
smiling. Yeah.
It gets you further down the line. Right, analysis is a huge number crunching exercise, effectively. This removes one of the pieces, one of the contention pieces. There's other contention pieces that are harder to remove.
Hey Dave, I was just wondering when to check for a bad execution plan, when we should know, hey, it may be a bad execution plan. How do we identify that?
Typically when you look at it and when you're reading through it and you just go, what the heck is that doing? Like, why is it not doing what I think it's doing? There's one of the real gotchas with Oracle is implicit type conversion. So you compare an integer with a string. It doesn't blink an eyelid at your syntax, but under the covers what it does is it converts via a function to a string. That disables the indexes. So you look at the query and you think, I've got an index on that column, an index on that column. Why isn't it using it? At that point, you have to understand what it was doing to get to that point. The other one is, again, what's the execution plan doing? Because you can look at it and say, I've checked all that. It still should be using this index. That's probably when it comes to the point of, OK, maybe now we need to consider our database maintenance problem and flush the caches, flush the plan caches every night, every month, every whatever. There's no hard and fast rules when you flush the caches, though.